So in linear, it's a line. You can't really mistake a line. In quadratic, what you're wanting to look for is that it comes back up at some point, or it goes back down depending on the shape. Exponential, it's not gonna have that turnaround point. So when you're looking at a graph, that's what you're looking for between these quadratic and exponential. Does it turn back up, or does it just keep going down essentially? Okay, the other way that we're going to look at, and this is what I'm not sure if you've done before, is how to look at a table and tell. Have you guys done the tables before? Yes? Okay. Well, in case you haven't, when you have a common difference, so see how to get from the first point to the second point on the y value, we just added 3, and then we add 3 again. When this is the same and this is the same, you have a linear function. So we call this a common difference. So when they have a common difference, it's linear. Now, common difference can also mean you're subtracting the same number every single time. So it's either adding or subtracting. Number 2, if x's are going up by the same and you have a constant multiple, so we're multiplying by the same number every time, that's exponential. So we call that the common ratio. Now, just like adding and subtracting could both be your common difference, multiplying and dividing can still mean you have exponential. So dividing would be like if you were halving the number every single time. And then the last one, you have to look at the second difference. So you first look at the linear like you would linear. What's the difference between 1 to -1, and so on and so forth, and you look to see, is this first difference the same? No. But you find the second difference, which means you're going to look at the difference between these numbers. When that second difference is the same, so we're looking here, that's a quadratic. So what we're going to be looking at today are both how to tell via picture and how to tell via table what kind of function we have. Okay, how many of you guys remember this from last year? How many of you remember some of it from last year? How many remember nothing? Awesome, okay. So let's go through numbers 4, 5, and 6. So this one's going to be looking at the graphs. So what do we have to do to start these? Plot the points. Okay, we don't need to do extra work. We don't worry about the table. We're given a graph, we're given ordered pairs. Let's just plot the points. So take a moment on your graph and plot your points. And you can go ahead and plot them for all of them if you want. So once you've got them plotted, start trying to look at which one do you think is exponential, quadratic, or linear. So who thinks they know which one is the linear graph?
6.
Good, number 6. Which one looks like the exponential? Number 4, the first one. And which one looks quadratic? The middle. So what was the key difference between 4 and 5? that told you one was quadratic and one was exponential. It went back up. Good. Okay, so that's how we're going to do it by looking at a graph. We're just going to plot the points and then look to see, does it go back up? Does it just keep going down, or is it a straight line? Okay, the next part of this is looking at the tables. So here's 4 tables that we're going to look at. I usually start with exponential. See if there's the common ratio or not. So is there a common ratio as we move along here? So am I multiplying or dividing by the same number every time to get from -3 to -1, -1 to 1? Okay, we can plus 2. Here we would plus 2, here we would plus 2, and here we would plus 2. Are all of these the same? So what does that mean? Linear. Okay, what about 8? What do you think about there? Do they have a common multiple or a common difference? So can we multiply by the same number and get to the next y value, or add the same number? No? Okay, so if you rule out common difference or common multiple, then I go and say, well, let's look at the second difference, which means I need to find all of these. So I'm going to start by finding the differences between my y's. And then I'm going to find the second difference. So to go from 1 to 3, I have to add 2. 3 to 5, I have to add 2. 5 to 7, I have to add 2. Are these, the second differences, the same?
Yes.
That means quadratic. So usually start with your linear and exponential. Check for those first, because those are usually the easier ones to notice. If it's neither of those, then go through the work of the quadratic. Okay. Okay, what about number 9? Do we have a common ratio or a common difference? You said it's neither. How'd you get neither? Okay, so if we do the common difference, let's see, what was this one? 19, and this one was plus 37. So it's definitely not linear. Here we add 6, we add 12, and here we would add something even larger. So definitely not the same second difference. And we don't have a multiple because I can't multiply 0 by something and ever get 1, so this is neither. So if you go through all of them and none of them work, you have more than just these 3 types of functions. You have actually a lot of different types. So this is a different type that you haven't learned yet. So we're just going to say it's neither. Okay, what about the last one? Does it have a common ratio or a common multiply by 2? So times 2. Oh, not plus, times. Here we times by 2, we times by 2. We times by 2, so that is exponential. And the reason I would say check them all, and I totally just spelled that wrong. E-X-P-I-A-O. Okay, the reason I would say check them all is because sometimes they might try to trick you and like throw in a random one at the end of your list that's not. So make sure you just check them all just to be safe. Okay, any questions about how to tell either via table or graph what's exponential, linear, or quadratic? So when we look at this first difference, were these numbers the same? So it's not linear. Were these numbers the same? No, so it's not quadratic. Can you multiply the same number each time to get from 0 to 1, 1 to 8, and so on? So if you answer no to all 3, it's neither. Okay, any other questions on the notes for 9?